All right, so this idea that we talked about with the magnet here a minute ago with the eddy currents being limited by the slices there, so the eddy currents are confined to those little strips, reduces the energy loss. In other words, the plates will swing through with the slits a lot longer because it takes longer for that energy to dissipate. So here's a transformer, and this would be the primary side. Typically, the primary side has the lower voltage and has the bigger currents, and the higher voltage side with lower currents tends to have the smaller leads. That's not always the case. I mean, you could always run the transformer backwards as a step down transformer or whatever, but this is typically, we call this the primary side and the secondary side. Now this transformer, I was able to bend the tabs to be able to pull this top off. And when I do that, hopefully you can see there's like these laminated plates. I don't know how well you can see that in the video. In other words, this is the iron core for the transformer. The coils are wrapped around, this iron core. And that's, of course, the different number of wraps is what changes the voltage. But if you look at the iron core, it is not solid. They actually have sliced this up into pieces. This is very common with transformers. And then there's thin insulating material between those plates. So each of those slices of metal, it's iron, but it won't conduct with the other piece of iron right next to it. Okay, so the magnetic field can go through there, but the eddy currents can't jump from plate to plate. We could not get a big eddy current going like this because it's broken up, but the eddy currents are confined to those little thin slices. And that increases the efficiency of the transformer quite dramatically for the same reason that cutting the slits there actually increases the, decreases the energy loss. It does not, well, I don't have it lined up right, but it doesn't stop nearly as quickly because the energy loss is much less. So this is, most transformers today are up in the 90 to 100%, close to 100% efficient in some cases.